On this worksheet, it's not obvious what the center is because there's not a name. On my test, you might see something like this. Point is center. Or you might see a letter there and then you'll see circle A. Either of those is an indication that that's the center. On this worksheet, we had to assume that number 4, that was the center, that was the center, and number 8, any others? Number 13, that was also the center. If you can't classify the angle, you're probably not going to get the question right. What kind of angle are we showing in number 1? Central angle. What's the rule for central angle?
Inside the center angle is arc.
All right. So what do you have for x, Dustin?
120.
120. And that's 120 because the arc is 120. Why is the arc 120?
Goes 360.
Circles 360. If you're stumped or stuck on a problem, it's probably because you're forgetting that the entire circle is 360. So x is 120 degrees. Always ask yourself or remind yourself of what it is that you're finding. If I'm looking for x, I'm actually finding an angle. So for this first one, I'm finding an angle. Number 2, what kind of angle is that if the vertex is right on the circle? What do we call that? Rachel? Inscribe. What's the rule for inscribe? The angle is going to be half of the arc. So, what do we have here? 68? If it helps, at least for these first few worksheets, write down what it is that you're looking at. How is this angle being formed? What are these 2 segments that are forming? What do we call those segments? Chords. So this is what I would call a 2-chord angle. If we look at the side board, a 2-chord angle has this rule which says add arcs divided by 2. You got to be careful which arcs you're using. If I want that angle, I could think of this almost like a bow tie or an hourglass. You want the arcs at the end of the hourglass, and that will get you the angle that's inside the hourglass. So 116 plus 122 divided by 2. What do we get? 238 divided by 2. Is that 119? What did I find? I found the angle that's trapped within that chord hourglass design. My arithmetic okay? What kind of angle is in number 4? What are we looking at? That's the center. More central angles. More angles that are equal to the arcs that they intercept. So I know that's 66. What is this? Diameter. What does the diameter do to the circle? Cuts it in half. So I know I've got 180 on this side. I've got a total of 180 on this side. That leaves me with 114 over here. What is that? That's an arc this time. Sometimes we're finding angles, sometimes we're finding arcs. You could have looked at this as a linear pair. You could have put 114 right there. That's also a central angle. That's going to be equal to its arc. What is this angle being formed by? We've got something inside, something on the outside.
tangent.
Tangent? Because it touches once, and then I've got another chord here. What's the rule for chord tangent angles?
The arc is twice the angle.
Right. This is double this, this is half of this is going to be 248. Now we've got a situation where we're looking at an angle outside the circle. And what do we call these two things that cut through the circle and intersect twice? What are those called? Secants? We got one secant. We got another secant. What's the rule for that? That's our second rule from angles and arcs. Anything formed by secants and tangents. If I want the angle, I subtract arcs, divide by 2. I happen to have exactly what I need. The arcs that are trapped or intercepted. 109 minus 53 divided by 2. Got 28. What is that? That is that angle right there. Same situation. Instead of secants, we've got tangents, but it's the same formula. I've got to take, subtract arcs, divide by 2. If this is 260, how much is left for the other arc? 100. What am I supposed to do with those? I'm supposed to subtract them, divide by 2. Right now you are assuming that these work. When we're all through, if we have time, we will be proving some of these. And once I show you why you are subtracting the arcs and dividing by 2, once I show you that proof, it's a similar procedure or proof for the rest of the rules. So I won't be showing you all of them, I'll just show you selected ones. It'll give you an idea of how you prove all of these little rules. This one looks like it is right on the circle. That's an inscribed angle, which means it's half of its intercepted arc, but I don't know the intercepted arc. If this is the center, then what's left for that little piece?
82.
82? Because we've got a semicircle situation because we have a diameter right here. Number 9, another 2 secant angle that's external to the circle, but I don't have both components. I need these 2 components, the 114 plus this little piece right here. How many degrees in a circle? How much is left for this little piece from all of that? 76. That's that arc right there. Now I can do my subtraction. Division by 2, 38. 19, the 19 is that angle. If I need this angle, there's a couple ways of doing this. I can focus on the hourglass. If I'm focused on the hourglass, then I want this arc on this end and this arc here. I don't know that arc. So if I can somehow figure out that arc, then I can use my 2 chord rule, add arcs divided by 2. What's left? That's 180, so over here would be 124. Now I can use those 2 to find the angle that's kind of inside that bow tie or that hourglass. What's the rule? This time I'm adding, finding an average of those 2. 260, 130. That is that angle. Or couldn't I have just done the same thing with an hourglass here? Could I have taken 44 and 56, added them up, got 100? That makes this angle 50. That makes this angle 50. Then I've got a linear pair with my 50. Very easy to figure out that the other one is 130. Don't forget everything you've learned up until this point. Vertical angles, linear pairs. Sometimes you're not looking for the angle. This is a 2 secant situation, which means I subtract arcs, divide by 2. So that's what I'm going to do. I'm going to subtract this arc and this arc. 146 minus x divided by 2. That's supposed to give me the angle. I just happen to already know the angle. Now you're just solving that equation for the unknown arc. How do you get rid of the 2?
Multiply by 2.
Multiply by 2. 146 minus x equals 52. Negative x equals, what do we got left here? $94. Is that right? What is that? In this case, that's the arc. Sometimes you're working backwards. This is a tangent chord angle. The rule is half of the arc. So this will be 144. That's this entire arc that's trapped inside there. The only amount that's left is the rest of the circle. That's got to be 216. On my test or quiz, it will be obvious whether something is a center. For this one, I am telling you that that is the center. That's still a chord. Even though it's a diameter, it's still a chord. That's still a tangent. It's still a situation where it's half of its arc. The arc just happens to be 180 degrees. So what is angle x? 90. Put a box there. That's this rule down here. Radius and tangent are perpendicular from our circle basics sheet. So that really is just a special case of our chord tangent rule. That's going to be 90 degrees. Number 14. What's the rule for 2 chords? From our angles and arcs worksheet, what's our rule? What are we supposed to do? Add the arcs, divide by 2. So that's what I'm going to do. Here's an arc. Here's an arc. Add them together. Divide by 2. And that is supposed to give me the angle that's within that hourglass. Double it. X plus 13 equals 22. Do a little subtraction. 9 degrees. And that goes right there. Last one is a tangent secant situation. Anything dealing with the tangents or the secants dealing with the angles and arcs means I subtract the arcs, divide by 2. But it's got to be the arcs that are trapped within. So this one here and the 83. What's left if I've got 115 and 83 within the circle already? That is what's left? That 162. 162, subtract the 83. What is that? 79. Divided by 2. At 39.5. My arithmetic correct? It's okay if you get decimals. 83, 115, that is 198. That leaves me with 162. Subtract 79. Divide by 2, 39. Are any of these difficult to do? No, but you got to memorize a lot of little rules and know when to apply them in certain situations. Times. This is our last set of rules.